Hello friends, welcome to next part in blog series on developing an OCR Vision AI. Welcome back. In past 6 videos, we wrote basic functions to support individual components. If you haven't seen those videos, I request you to please see some parts to get some background. In this video today, we are going to glue it all together to make it work. We'll combine these functions together to achieve goals of our application we are building. So let's get started. Let's set up our main function now. This is the logic we are going to build in this block today. We'll write some more functions to build this logical process, which helps us read content of the files and then write the data back to SQL and ChromaDB. This is the main entry point of our application. So in video number 2, we discussed the file drop functionality. Now we'll focus on file processor.py file. Number 1, read metadata. So here we are going to extract the file type, name, size, creation date, and creator, etc. Step number 2, process content. Here we are going to use PyPDF, Tesseract, and Llama Vision models to read the file's content. Step number 3, quality check. Now here we are going to pass the content and metadata to a QC agent so that we can assess OCR quality using a specific instruction and context. Number 4, store data. Finally, we are going to save the content to SQLite and ChromaDB. And later, number 5, finalize, we are going to wrap everything and create the read data model, and we'll create a web app for a user interface chatbot. This is the main entry point of our application. So if you recall, in video number 2, we discussed the file drop functionality. Now we are going to refactor content on this file processor.py file. So first open the bash script file, and if you see the line where it says python3 file underscore process.py, now you need to change this line to add a parameter, which is last file. So what we did, we are still calling the same script, but now we are passing this file name as a parameter. So now open file underscore process.py file and start updating it. So we'll update to make it accept a runtime parameter. That is the argument where it says create underscore timestamp underscore file function. Just add arg, that means argument, inside the parenthesis. So where it says name equals to main, if name equals to main block. So inside this if block, where you need to make it to read the arguments. So literally you have to write it, say if length of system.argument is greater than 1, that means there are more than one argument passed to this script when it's called, then pass sys.arg 1. So that's like, we are taking the first argument to create underscore timestamp file function. So one last thing. Now, because the name of the create underscore timestamp file, it's a little bit like, we named it earlier because it was creating the timestamp file. So let's rename it to something called main, which is more appropriate because now this function is doing a lot more than creating a timestamp file. So just to recap what we did, first of all, from the bash script, we passed the file name as an argument to the file process Python file, which is reading the file name now. Okay, and now we are calling the main function. Now we are not done yet because our objective is to capture all the metadata about this file. So inside our main function, we should print all the file metadata. So you will see in a minute why this metadata is very important to us. But this is how you get the file metadata. Now let's write a simple Python function which, given a file name, read this file content. So here for now we'll just assume that we are given a good PDF file. At this point, don't worry about if the file given to us is not a good PDF, because we are going to validate the content later on anyway. So let's go back to our main function and add logic to read PDF content. You see this content where it says -- logic to read PDF. We are going to write code to read PDF file there. So now write from PyPDF import PDF reader, and then you write reader equals to PDF reader and pass the file name, which is file name underscore.pdf or whatever your file name is. So this line, what is going to do is going to initialize the PDF reader object to read the PDF file located at file name.pdf. Then you write number of pages. So number of pages is a variable. Simply what it does is just calculate the length of the reader.pages. So this line calculates the number of the pages in the PDF by getting the length of the pages attributes of the reader object. Next you write message. So message equals to, you take an empty string and then you join and you create a comprehension, that means a for loop. So for page in reader.pages, you just extract the text and you append it to the same message variable here. So this line finally what it's doing is extract the text from each page of the PDF. It uses a list comprehension to iterate over the pages in the reader.pages list, and page.extract text, extract text. It extracts the text from the each page, and finally use the join method to an empty string. So what it's going to do is going to concatenate all the extracted text into a single string. And when you print it, so here you don't want to print the entire file here. So what I'm doing here, print message equals to $100. So what this means is this line is going to print the first 100 characters of the concatenated text stored in the message variable. If you recall our last video, we wrote a function named QC_agent. That means quality control _ agent. What this function does, it accepts three parameters: context, instruction, and message. So in this section, we are just going to focus on building these context, instruction, and message. So message is something we already know because we just read a PDF file using PyPDF package, and whatever the content it reads from the PDF file, we store the content into this message text variable. So now let's go focus on building these two variables here, which is context and instruction. Instruction. So here we are going to write, please respond in one word only, true or false. So why we are saying response in one word? Because if we pass this kind of instruction to Llama or ChatGPT or whatever the Gen AI models is, it will return only one word, true or false, so that we can decide whether to keep PyPDF content, and if not, then we can move on to other OCR logic like using Tesseract to read images, or similarly, if Tesseract doesn't work, then we can use some other model, say Gen AI, LLM vision based model, so on and so forth. So that's the reason we are passing the instructions like this, which clearly says please respond in only one word, true or false. Context. So here we are going to write, so I just use a PyPDF to read content of a file, and I want to make sure that this text appears to be a valid acceptable text or not. Example, so here we are saying file size. So usually, where file size is equals to the number of the words. So what I'm trying to tell you that, okay, if you're using the file metadata, that's why the file metadata is very, very important. So when you're passing the file content, please also pass the metadata as well. So indirectly, what you're asking Gen AI QC LLM model to reason about is going to reason that, okay, is going to help make a decision. For example, a PDF file is of size 10 MB and there are only 10 words in it. So obviously this is not right. So this information, you passing this kinds of context with the file metadata, that's why it is very, very important, so that your LLM model can reason about it. It will say, hey, your PDF file is 10 MB and there are 10,000 words in it. That seems okay. So this looks like a good valid content. This means this is a good OCR engine. So this extra context information is going to help LLM make smart decisions. Now let's put it all together and call our QC agents with given specific instructions, context, and message. So here simply the QC engine will make informative decisions that whether given the file size and other file metadata, PyPDF package was able to read the content correctly or not. So if the QC agent says yes, that means it returns a true, the file content stored in the message variables appears to be good, then we can use this PyPDF OCR content. And further, we are going to store this data into our databases like ChromaDB or SQLite. And if not, if this doesn't appear to be a valid content, then we can move on to the next steps, for example, saying using Tesseract. So let's wrap it all together and go back to our main function. So here, just to recap one more time, we did try PyPDF to read content of PDF. We captured PDF content into a variable called message, and then we defined instructions, context. And finally, we called our QC agent functions with these parameters: context, instruction, and the message. And what we are asking this QC agent to do, it is to verify the results of the output from the QC results are good or not. And then we change this code to wrap into an if-else statement so that you can see it here. First, we call PyPDF and verify the results with a good quality OCR engine or not. If the results are good, then we don't need to move any further. And I guess we can just store these results directly into ChromaDB and SQLite. Again, if the results are not satisfactory, that means PyPDF fails to read the file content, which is a very valid case if you're reading an image. So for example, I give you a PNG or JPEG or GIF file, then you may not be able to use your PyPDF. So in that case, you may want to call another OCR tool such as Tesseract. And then if Tesseract doesn't work, then you can use other Gen AI vision models and try to read image text at any point that, the whole point is at any point when you think that PyPDF or Tesseract or a Gen AI vision model is able to read the file or image content, you just exit from the if-else statement logic and proceed to writing results to ChromaDB and SQLite. So one last thing, we already covered these two databases functions, that how to write the data to ChromaDB and SQLite in previous videos. So I highly suggest please go back and watch those videos, and that will tell you how to write insert statements. All right. So now just to wrap it up, let's see how a Tesseract file read looks like. So again, like you can, get this code from the ChatGPT or any other coding model here. So here you simply write from PIL import image. So this imports the image class from the Pillow library, which is used for opening and manipulating image files. Then you write import PyTesseract. So what this package does is imports the PyTesseract library, which is a Python wrapper for Google's Tesseract OCR engine. Then you write image.open. So this line is going to open the image file specified by the image path. And then you're going to store this into a variable called image. And then simply what you do, message equals to PyTesseract dot image to a string, and you pass that image. So what this line is going to do is going to use the Tesseract to extract text from the image. And this image to string function, it processes the image and returns the extracted text as a string. And then you can take that string and finally store it into your text variable. So let's review one last option before we wrap up this blog. So for example, you tried PyPDF, it didn't work. You tried Tesseract, it didn't work. So then you can use vision models to work as an OCR. So please see, this is the very, very last option because it could be an expensive method depending on your LLM API subscription. But there are ways you can do that. First thing is you need to install a couple of the packages here. So just issue a command saying pip install TorchVision transformer. So this command is going to install the TorchVision and transformer libraries, which are necessary for using the Llama vision model. And then you call Llama for image classification and Llama processor. You need to import from the transformer library. Next, you import the image. So image is imported from the PIL, which is Python imaging library for handling image files. Now Torch is imported for tensor operations and model inference loading. So for model inference loading and the pre-trained model in processor, you just say model equals to Llama for image classification dot from pre-trained, and you pass the Llama vision model inside that from pre-trained method here. All right, next line you write processor. So processor equals to Llama processor dot from pre-trained method. Again, you call the from pre-trained method and you pass the Llama vision model here. So basically what these lines, they load the pre-trained Llama model and its corresponding processors. Next, you write the input. So input equals to processor. You call the processor function here, and here finally you pass two parameters here, images. So images equals to image.open, and this is the file name, what you the image which you want to read. And second option is return underscore tensor equals to pt. So what this line is going to do, this line opens the image file specified by file name and pre-processes it using the processor. Okay, the pre-processed image is converted into a tensor format. So that's what PT stands for. PT stands for PyTorch tensors. And next you write with torch.nograd and output equals to model, and you pass the inputs there. So this block, particularly this block, is going to perform the inference using the pre-trained model. In our case, which is Llama-vision model here. And the torch, when you say torch.nograd, this context manager is used to disable gradient calculation. So here we are saying, we don't need to calculate gradient here. We just want to, run an inference and want to read the content of the image. So in this case, it's not needed for inference and it's going to save memory. And finally, you just say message equals to processor.decode, and you pass the outputs.logits.argument max -1. So this line is going to decode the model's output logits to extract the predicted text. So basically this is, you can also get this code from the PyTorch library, or if you go to Hugging Face, you'll be able to see that. That's a very basic implementation of running an inference on Llama vision models here. That's all I wanted to cover in this video today. So just to recap, in this video we combined all the methods and we implemented an entire process workflow. So in next blog we are going to create a chatbot, and finally we'll create a web app kind of a thing to serve our Vision OCR AI. Stay tuned. Thank you for watching.